Welcome back to my part. And before we looked at organization charts, and now one question is also which roles do we need in an AI project? And maybe you can tell me a little bit what roles you have come across, which ones you have heard, and then we see how they differ. So I think the classic role is a data scientist. Any other roles, like most of you are doing your internship right now, which roles have you come across in AI or data science? Yes.
Prompt engineer.
Okay, a prompt engineer. Yes. Louder. Data analyst. Okay. Any others? Yeah.
Software tester.
Software tester. Okay. Yeah.
That's kind of usual jobs like with architect and service or with HR.
Well, maybe more AI specific roles. You also raised your hand. Data management, governance function. Okay. Yeah.
Management.
ML engineer or data engineer. Yes. So there's not that one definition for these roles. Rather, wherever you look at, they may be defined differently. Something I felt about 10 years ago, the role of a data scientist was becoming very popular. And in that time, um, companies wanted to do, especially if they worked with consulting partners, want to do a lot of experimentation, try out some stuff and see if something was in the data that they could potentially use or not. And and a lot of data scientists were needed suddenly. And at that time, there were not these AI programs yet, like the ones you're taking here. So there were computer scientists with some AI background, but overall, the role of data scientists was very diverse. Mathematicians, people with a background in statistics, economists. Even one of my friends who studied political science started analyzing some data at the end of his studies. So there was a very diverse background in this data science field, and that's something we still see today. But at some point, companies said, well, we don't just want to do experimentation, we want something concrete. So there's often this sentence, maybe 6 or 7 years ago, playtime is over. Build concrete products or services that run. And for that, we need to know more than some statistics, especially with regards to computer science, software engineering, how to build large-scale systems that work, that run efficiently and reliably, and that you can scale up and down. And then there was the role of a data engineer or ML engineer. This role differs a bit to the scientist role. It's still people doing science, but rather also mainly engineering and building concrete stuff that works. But these two roles, they are not contradictory, they are complementary. So a data scientist may early look into data, build some model, but then when you need people to scale these models, run them reliably in some infrastructure, a data engineer would come into play. And usually they need to know a little bit about the other's work. So a data engineer may not need to be an expert in the latest machine learning model or in some details, but they still need to know what the data scientists are doing, and the data scientists still need to know what the engineers are doing in order to build these systems and work together. So sometimes there's strange advice on the internet, like someone wrote a data or why data scientists shouldn't need to know Kubernetes. It's something I disagree with. As a data scientist, this may not be your main task working with Kubernetes, but at least you should know a little bit what it is and how it works so you can interact better with the data engineers. While the data engineers may not need to know details of some specific machine learning model, but they should still know overall what it is and what it's useful for. So again, sometimes advice I'm a bit skeptical about. Now, how do you start a machine learning project actually? There's something that came up on the internet maybe 8 to 10 years ago. It's called the Machine Learning Canvas. Anyone has seen this? It's a one-page document that you can use early on in a machine learning project, and it's just a few fields that you would fill in. One is what is actually, so in the center, the value proposition. What is the value your use case would add? And I think that's super important because before we talked about that a lot of projects fail because people come up with a solution, but not really, that doesn't really fit to concrete problems, but rather creates new problems. So what is the value we are proposing with some use case? I think that's most important. And then you have certain prediction task, something you want to predict. From that, you want to infer certain decisions. You can ask yourself, how do I make these predictions? What is the impact of all of that? Then how do I collect data? Which data sources and which models do I need to build? And on which features do they run? So this is a one-pager. You can find it for free on the internet in various versions, and you can just print it out. And this could maybe in an initial use case workshop be helpful to take a few notes and see what do we want to do, which predictions, which decisions, which data do we have the data, and maybe which models we could explore. And then you see early on whether this maybe makes sense or maybe not. And it can help when you want to prioritize use cases. So in a typical use case workshop, a couple of use cases come up, but some of them are maybe more tangible than others because you have the data sources, the data collection is possible. If it's not available, then maybe you would prioritize and focus on a different use case. So this is something that is super helpful, and I also use it a lot in workshops when I sit together with my clients. There are obviously also digital variations and so forth, but it's something I actually use quite a lot. I also published a book a few years ago. It's called Innovative Technologies for Market Leadership. And in there is a chapter which is called Unlocking the Power of AI for Your Business. And in that book chapter, I share various advice when it comes to AI and how to take advantage of AI and build stuff that works. That book chapter is also available in Nextcloud. And you can read it on your own, but most of the stuff I'm saying in this course is probably most of what I'm saying here already covers this book chapter. It's also about specific roles, how to establish an AI competence center, and some other stuff, or that you should use AutoML, which we had looked at already, but you are more than welcome to read this book chapter for revision or further reading. Then there's another interesting best practice. I mentioned there's this data science in practice book from Peter Norvig and a couple of other authors. And this is a book I read sometime last year or 2 years ago after it appeared. And it provides lots of best practices how to succeed with data science projects. And what they have in there is, for example, the data science analysis rubric. So what is that? It's sort of a table or a couple of columns for a use case where you need to think about, where you get very essential questions when you start looking at a potential AI or machine learning use case. So one question is the data tractable? What's your technical approach? And various aspects in terms of dependability, which means, for example, privacy, security. Is it abuse resistant? Is it resilient? So you could fill this in quickly when you do an initial workshop about use cases. So this approach is not actually contrary to the machine learning canvas. Rather, you can see it sort of as an extension from certain perspectives. And there's the question of understandability. Is this needed or not? So do we need explainable AI or not, or causal AI? Do the results need to be reproducible? Tomorrow in the next chapter, we'll be discussing in detail explainable AI, some pros and cons. We wonder, are there clear objectives? How do we deal with failures? And then there's one big extra section, which is called ELSI, which stands for ethical, legal, and societal considerations. So tomorrow we also look in detail around laws that concern AI regulation. There could be ethical dilemmas with your use case, and there could be an impact on society. So you need to be thinking about that as well. And there are a few examples. Say you want to build various AI systems around routing and autonomous cars. If you want to do a route finding, there's enough data, there's lots of data available. The approach is feasible. In terms of dependability, it's feasible, but there are risks, but probably minor risks when it comes to route finding. And there are probably not that many ethical and legal issues. But if you build an autonomous car, say at level 5, there's probably a lot of data available, but the feasibility of building something like this is unproven. Probably you would need explainable AI, and there are lots of challenges around ethical, legal, and societal that are still unsolved today. And in terms of failures, well, with your route finding, errors would slow you down, but it would not lead to a massive disaster, also assuming the driver still checks their route from time to time and doesn't just drive into a river, even if the routing system tells you. It still happens from time to time. I notice people complain or they end up in the opposite end of the country because they typed in something wrong in their navigation system. So that was in the news some years ago. Some lady only had to drive 30 kilometers, and after 10 hours, she ended up at the opposite end of the country and then called the police and just didn't know how to get to the destination. So, yeah, but with a fully autonomous car, all of this becomes more challenging. And there are, for example, you need great safety. Feel free to look into this book, Data Science in Context. I had it very initially in the slides, and Peter Norvig and some of his associates. So Peter Norvig, I guess you all heard about Peter Norvig, right? One of the most famous AI researchers, who is the director of research at Google and wrote this very famous book together with Stuart Russell about AI, a modern approach, that we have now, I think, in the 4th edition for a couple of years, which is my favorite AI book, by the way. And then there's something else I came across a few months ago. I saw this on the internet. There's a company, you can find them, the URL is fastbreak.one. They offer various tools and kits for project management. And they also started offering something for AI. And when they had announced this, I asked if I could get a kit here for our class. And what this kit is for, so there's the hard copy version, but there's also a digital version if you wish. So they also sell this, but this is not an ad for that company. It's just want to show you a little bit what's available on the market. So they have digital solutions, they have the hard copy solution. And when you're early in an AI use case workshop, they have different cards in here. They have pattern cards. So what kind of pattern do you actually want to find? So is it maybe a supervised learning approach, an unsupervised learning approach, or is it something totally different? I will bring the card set tomorrow because I didn't know if we would already be at that stage today after the guest lectures, because they finished a little bit earlier than expected. But I'll share this card set tomorrow morning so you can take a look. And there are lots of cards about patterns, about the purpose. So it's the purpose of the AI system. in what kind of ecosystem are you, which kind of technology could be needed. And then you can spread out these cards. For example, it's in an industry 4.0 ecosystem, the use case. Our purpose is we want to improve customer satisfaction. What we are doing is, in fact, quality control. So this would help us to improve customer satisfaction about our output in a factory process. We want to optimize the quality control. Maybe so far it was a more classic computer vision approach based on filters. And now we want to put in some machine learning approach. You can also think about monetization. There are different monetization cards. Here we could say, well, it's volume based. We simply want to do much more quality inspections, or this is how it will pay off. Internally, we use deep learning. We're dealing with customers. So I've just combined some cards. They're not necessarily fitting very well for one use case. The data we get is sensor or real-time data. And then you have for the monetization, for the function, for the data, for the technology, ecosystem, multiple cards. And they write something like, we have these 56 component cards, and then they have identified like 28 very common AI use cases throughout hundreds or thousands of use cases they found like 28 patterns. And for each card, if you turn them, you get some more information on the back about that pattern. Or here, for example, so this would be the pattern, quality control and supervision. And then if you want to learn more about how to monetize in terms of volume-based, or you want to learn more about industry 4.0, you just flip the cards and you see what's at the back. It's just some initial thing in a use case workshop, or when you identify use cases. There is a digital version. I've also tested in a few workshops now this printed version. It's still something else if you bring people together and they sit at a table drinking coffee and you spread the cards and you try to come up with something useful. But some people prefer the purely digital one. And they are selling these cards. They are selling the digital version, and I'll share the cards with you tomorrow with one set, so you can test it here. And we'll see this tomorrow. So these are multiple best practices. And today we're finishing a bit earlier, so it would obviously be really cool if you spend some time, for example, also reading this book chapter, because there's still a little bit of time until 5 p.m. And there's also another very large literature review about AI and business that I came across a few years ago. Just if you want to get some further insights about concrete use cases where AI is adding business value and that get published. There's a very good survey paper on this. As you know, you should also slowly start thinking about your case study. Tomorrow, we are looking at a lot of more challenges. We are looking at contemporary challenges, for example, at ethics, explainable AI. We will see how various countries compete with each other. We will see how AI impacts the jobs market. We will also see some of those, what I call prophets of AI doom, those people claiming AI would end the world, especially with regards to the technological singularity. We'll be exploring all of this tomorrow, because these are very recent challenges. And then tomorrow, we will also look in detail into legal challenges, in particular regulation, patents, copyrights. We will also look more into military applications. So Alex has already presented some. We look at some more of the theory and laws, and whether we're actually able to build safe military AI systems that are compliant with laws. It's actually possible to do this, and they will not suddenly turn nuts and kill everyone, even though the prophets of AI doom keep claiming this all the time. And there's also now some new laws in progress with regards to AI at the workplace, and I'll be sharing some insights about this. So for your case study, to define it in detail, it will be very helpful for you to hear these 2 more chapters tomorrow. However, you can maybe already look for your group members. So it's 2 to 3 students per group. That's important. Not 1 student, not 4, 2 to 3. And maybe you can already think about a company, or you can search something online about a company or a case study that you found where an AI implementation failed or worked out well, and what you need to pay attention to from the perspective of this course. So you can discuss in your case study, obviously, and you have to some technical stuff, but not purely technical, like how do I implement this AI, but also thinking about these process models, like Katja talked a lot about them. That could be something, or maybe something around AI agents, Gen AI, or how you address these promises and hypes. And for more details, what you could think about in your case study, we'll be seeing these 2 remaining chapters tomorrow at 8. I'm doing a lecture tomorrow from 8 to 11. Then at 11, we have Christoph, the former board member of Siemens Healthineers, who will give a guest lecture, and probably we still have some time then after lunch to discuss the remaining topics. Are there any questions from your side at the moment about the content, about the organization of this course? Yeah.
Question about how we present our case study. So, is there any specific guidelines we need to follow, like pages or more, and what are key things that we need to put in our?
Yeah, I think the presentation of the case study is something we'll talk maybe tomorrow after the last content. For now, it's maybe you need to do an earlier step, think about a possible case study and someone who wants to work with you on that. And then maybe how to present it, we'll talk about that tomorrow after we finish the content. Any other questions? All right, then it was great to see you today, and I look forward to seeing you tomorrow. Enjoy the afternoon.